Tired of long wait when you need service? Well, we create to solve the inefficiency of long queue and improve customer satisfaction. Meet introduced to queuing theory, the science of waiting line. A mathematical framework to balance service cost with customer wait time effectively. Say goodbye to excessive time. Wait. How it works? It uses statistic model to analyze arrival, lambda and service rate mu to predict queue behavior. Plus, it maximizes the operational efficiency, allowing for better staff allocation. Minimize waiting line for customer, enhance overall service speed, increase satisfaction with reduced delay. Transform your business with effective queue management, reduce customer frustration and improve loyalty. Sound interesting?
Assalamualaikum and hi everyone. Today we will present our queuing theory project for Nasi Lemak Tapah Bersatu. First, I will introduce our group members. The first one is Muhammad Adam Daniel bin Muhammad Safari, and the second one is me, Fifi Farisha binti Rostan, and the third one is Putri Noelia binti Izaham, and the last one is Aina Bakisha binti Muhammad ZA'IM. Nasi Lemak Tapah Bersatu was located in Cafe Pusat Pelajar UiTM Campus Tapah. The stall is popular among students due to strategic location within the campus. The operating hours are Monday to Friday, 9 a.m. to 3 p.m. and the stall is closed in Saturday and Sunday. In terms of business type, it operates as a food stall specializing in nasi lemak. The stall is served by two servers. For the queuing system, the stall is used a single queue with two servers, which follows the MM2 queuing model. The system is observed and analyzed to understand customer flow and service efficiency. The slide shows student queuing at the stall during peak hours, and it also shows our observation process where we record customer arrival and departure in 1 hours. This video shows that student queuing in a single line at Nasi Lemak Tapah Bersatu during peak hours.
Moving on the characteristic of queuing system for Nasi Lemak Tapah Bersatu, we have broken this down into three main components: arrival, waiting line, and service facilities. First, let's look at arrival characteristic. For population size, we classify the size of population is limited. This represents the specific student and staff population of UiTM Tapah who visit the cafeteria. Next, arrival pattern. The arrival follow a Poisson distribution. This simply means that the customer arrive at random interval rather than a fixed schedule. Next, customer behavior. We observe the behavior of patient and bulking. While the more students are patient and willing to wait, some do bulk, mean they see a long line and decide to not join at all. Next, we look at waiting line. Length of the line is considered unlimited. This because the cafeteria is a open space, so there are no physical restriction on how many people can stand in the line. Queuing discipline. The system operation on the first in, first out. This means standard fare method where customers are served strictly they in order they arrive. Finally, for the service facility, first, service configuration. Based on our observation, this is multi-service system. Next, for the phase, this is single phase system. Entire transaction, ordering and scoping the nasi lemak and paying happen at one station before customer leave. Service pattern are exponential distribution. This means time taken to serve each student varies. Some order are quick while the other take a bit longer.
Next, I will present an analysis using the MMS queuing model. In this system, the actual arrival rate is 107 customers, which represent customers who arrive at shop. In addition, we assume that there are 70 customers already inside the shop and eating at the beginning of the observation. These customers are already in the system and are not new arrival. To analyze the system under a busy or peak hour condition, the model uses an effective arrival rate of 177 customers to represent a heavily loaded system. The service rate, which is mu, is 102 customers per unit time for each server, and there are two servers operating in the system. These parameters are used to evaluate queue length, waiting time, and overall system performance. So this is our result that we obtained. The average server utilization is 0.87, meaning the servers are busy 87% of the time, which indicates a high workload. The average number of customers waiting in the queue is 5.28, while the average number of customers in the system is 7.02. Customers spend an average of 1.79 minutes or about 107 seconds waiting in the queue, and the total average time in the system is 2.38 minutes or approximately 143 seconds. The probability that the system is empty is 0.07, showing that the system is usually busy.
Next, we will be moving on to the waiting line characteristics, which includes the length of a line, queue discipline, and service configuration. So, firstly, for the length of a line, it is unlimited. This is because the physical space at the shop, which includes being in an open space, allows for a long queue, and there is no restricted limit on how many customers can join the line at a time. Next, the queue discipline. So it is first in, first out, which means that the customers are served strictly in the order they arrive. So all the customers will wait in one main line before being directed to an available server. And the first student in line is the first to be served by the server. Lastly, service configuration. So it is categorized by two primary factors, where the first one is number of channels and the second one is number of phases, which is steps in service process. So for number of channels, it is multi-server. This is because there are two servers providing the service to entertain customers simultaneously. So for the second one, number of phases, it is single phase. This is because the service is completed in one step, which is ordering and paying happen at the same station. In the waiting line here, we can see customers arrive and wait in the queue if all servers are busy. And when a server becomes available, the next customer in line is served. This also shows a multiple server system with two servers at the counter, which helps to reduce waiting time. After being served, customer move to the service area shown at the bottom, where they receive the service and leave the system. In conclusion, from evaluation of service performance, we could see the two servers are able to handle a high volume of 177 arrivals per hour. The system operates at 87% utilization, meaning that the servers are highly productive. Despite the high arrival rate, the average waiting time in the queue is only 1.79 minutes, and customers spend an average of 2.4 minutes in the entire system from joining the line to receiving their food. Next, to answer questions regarding adequacy and customer satisfaction, are the servers adequate? Yes, because although the servers are very busy, which they has 87% utilization, they effectively prevent the queue from becoming unmanageable. And then, are customers happy? Yes, because a waiting time of under 2 minutes is considered excellent for a busy campus breakfast spot, ensuring high customer satisfaction and goodwill. Overall, For the project learning outcomes, we were able to learn how to apply Topic 5 waiting line and queuing theory to a real-world business environment at UiTM Tapah, and also gain proficiency in using POM/QM software to calculate operating characteristics that are not easily visible through simple observation. We also realized that managing a successful business requires balancing the cost of service, which is number of servers, with the cost of waiting, which is customer time.